In order to find the moment of the forces developed in the belt having a tension of 52 pounds about point A, we can utilize our scalar formulation since the force is in two dimension. So to start, let's go ahead and resolve our force into its x and y component. We can do that by utilizing the angle 30 that a plane perpendicular to the force is making with the vertical axis. That means that our force vector will make the same angle with the horizontal axis x. So taking the cosine function, it will give us our x component. Similarly, we can project this force vector along the y-axis by utilizing the sine function. Now, once we have the force components, let's calculate the perpendicular distance of each one of these components with respect to point A. That will be our moment arm. Since the force vector is along the x, next the perpendicular distance will be along the y-axis. Now here we are given a distance 8" from point A to the center of the wheel, whereas the distance above it needs to be calculated. Using the radii of the disc, that is 6 inches, taking the cos function will project it along the vertical axis. So the moment arm in this case will be 8 plus 6 cos 30. Now let's go ahead and multiply the force with the moment arm to calculate the moment. Now one more thing, since the force is acting towards the right and the perpendicular distance is going downward, this case it is making a moment in a clockwise direction with respect to point A. Next, let's go ahead and solve for the moment generated by the y component of force F1 about point A. Now again, the moment arm will be perpendicular to the force vector, and since the force vector is along the y direction, the moment arm will be along the x direction. Now to calculate that, here we are given the distance from point A to the center of that plate is equals to 5". So we need to subtract a distance shown here in order to calculate the moment arm, which can be calculated by taking the sine 30 function of the radii of the plate. Subtracting the two quantities will give us the moment arm. Now, in this case, since the moment arm is towards the left of the force vector pointing upward, it is going to create our counterclockwise moment. So it will be taken as negative. Simplifying, we get the value of total moment as 542 pound-inches. Next, let's go ahead and solve for the moment of force F2. Now, the magnitude of the force is still 52 pounds since that is the tension in the belt. So we can go ahead and resolve this force also in its x and y component. Now, this time the radii is making an angle of 20 degrees from the vertical. That is a plane perpendicular to the force vector. So the force vector will make also an angle of 20 degrees from the horizontal x-axis. Similarly, we can go ahead and resolve that force in its x and y component by taking the cos 20 function and sine 20 function. Once we have resolved the force, let's go ahead and figure out the moment arms. Starting with the x component of the force, since the force component is in the x direction, the perpendicular distance of the moment arm will be in the y direction, which can be calculated utilizing the distance from point A to the center of the plate, that is 8 inches, and subtracting the distance from the center to the force vector location on x-axis, which can be calculated by taking the cos function of 6 inches. So our moment arm in this case will become 8 minus 6 cos 20. Now, next we have to identify either it will be going in the clockwise direction or counterclockwise direction. Now, since the force vector is pointing to the right and the moment arm is going below, it is going to create our clockwise moment. So that's why we are taking that as positive. Next, we can go ahead and look at the vertical component of the force pointing upward, and the moment arm will be along the x-axis going from the force vector to the point A, and we are looking for the perpendicular distance here. Now, in this case, we know the distance from point A to the center of the plate is 5 inches. We need to identify the additional distance from the center to the force vector along the y-axis, which can be calculated by taking the sine function of the radii. So 6 sine 20 will be that distance. Now our total moment arm will be the sum of 5 plus 6 times sine 20. Since the force vector is upward and moment arm is to the left of the force vector, it is going to create our counterclockwise moment. That's why it is taken as negative here. Adding the two terms give us our total moment of 10 pound inch.